what is your definition of a database? Writing properly. Okay. So you can say a database is a collection of related data, right? So when you say related data, it depends on why you are collecting that data, right? So if you have a hospital application, for example, so in that case, related data would be data related to patients, their prescriptions, appointments, right? On the other hand, if you have a platform like an e-commerce platform, then related data would be data about products, customers, right? So the stock, all those, right? So you think of database as a collection of data. You could also think of it as a place where you're storing the data, right? So a database is a place where you store related data. So when you installed your software, you'd have installed two things, right? So one would be your database server, right? And then you'd have installed a client, which is the workbench. So if you think of your server, right? So at a very high level, you can think of it like you have a physical storage, right? Or what you call the permanent or persistent storage. You can think of it like your hard disk, right? So this is the memory where the data is stored. And then you have software, right? A set of software programs called the database management system, right? So the DBMS, database management system, right? So this is a set of software programs. So if you want to look at a comparison, right? So this is very similar to the operating system that you have on your laptop or your PC, right? So you cannot, as end users, we cannot directly interact with the hard disk, right? So you need some interface through which you are interacting, and you need a set of programs which will allow you to interact with the hardware. So on your laptop, it is the operating system, right? You might have a Windows system, you might have a Mac system, you might have a Linux system. So these are all the operating system, right? So the set of software which controls how you store and how you interact with the system, basically. So without that, nothing is going to function. Similarly, if you're buying a cell phone, for example, the operating system, the Android or the iOS, right? So this is the thing that controls, the thing that controls everything. So similarly, when you think of a database server, the heart of the server is what you call the database management system, right? Which is a set of software programs which allows the end user to interact with data, right? So finally, the data is stored in some format on the disk. But then we as end users cannot directly go and write into the disk, or we can't retrieve data from the disk also. So what we do is, okay, that is a person. It looks like a fish, but this is a person. Okay. So this person interacts with a graphical interface, which you call the client. So what we will do is we will give some commands which sound like English, right? So store, restore, insert, update, delete, right? So these are all words that we understand, commands that we understand. So that is what we will type in the client. The client will take whatever you are typing, right, and transfer it to the DBMS. So the DBMS should understand what you are saying, right? So the commands that you are giving, execute it. And if at all you need some response, that will be sent back to the client, right? So this is what you have installed on your laptop: a server, database server, and a client. So the database server that you have installed is the MySQL server, and the client that you have installed is called the workbench. Right? So whatever you type, that you will be interacting with the client. The client takes the responsibility of transferring what you're typing to the DBMS, DBMS understands what you want, executes it, and a response is sent back, right? So because it is the DBMS that controls the entire flow of data, depending upon how the DBMS stores and restores the data, there are different types of databases, right? So basically based on storage, you could say, okay, let me open that presentation, just a moment. So depending upon the way the data is stored and restored, right, you have different types of databases. So basically what kind of DBMS you are using, right? So that is the one that decides what kind of database you have. Let me just open D1. So there are many ways in which you can store and retrieve data. So one of the basic ways of storing is what you call hierarchical storage, right? So what we are interested is not in hierarchical storage, but then let us get an idea about the other ways of storage, and then we will move on to what we are interested in, right? Can you give me a moment? Let me just get a different chair. Just 1 minute. Sorry. Right. So depending upon how you store, right? So one of the ways of storing data is what you call hierarchical storage. So what this will do is it will store data in a hierarchy, right? For example, above this, you might have university. Under university, you will have college. Then under college, department and infrastructure. Under department, course, teachers, students, right? So if at all you have to store details about a particular student, the whole hierarchy of information will also be available to you. So let's say you have a student whose student ID is 1, right? Whose name is some George, and he is taking MySQL course, right? So the whole information about George is stored in a hierarchical format. In which university, which college, under which department, which course, which teacher, right? And under the course, what theory and labs are there, right? So this is how George's data will be organized and saved and retrieved. So if you have a DBMS, if you have a database management system, which stores and retrieves data in hierarchical format, such a database is called a hierarchical DB. Right, so let's just write it as hierarchical DB database, right? But in the case of hierarchical database, it's a little difficult to find relationships, because if you see, there is no direct connection between a teacher and a student, teacher and course, right? If at all you want to find the connection between the student and course, you have to go one step up, right? And then from here, you have to trace the connection to the course, right? So the student is connected to the course through the department. Similarly, lab and infrastructure, right? If you want to find the connection between, let's say, computer lab and the infrastructure in the college, you need to traverse up and down the hierarchy to get the connection, right? So although this was quite popular some time back, right? Especially IBM's database servers used to have this hierarchical storage. But this people found a little tedious to write queries, right? Because finding the relationships was a little complicated. So the next level, right? So a slight improvement or change over hierarchical DB was what they call network DB, right? In the case of network DBMS, there are many connections here. Right, so as you can see, there is a direct connection between course and faculty, course and student. And so here you can see there is a lot of interconnections, right? But still, maintaining these relationships is a little difficult, right? But once you create these connections, retrieving data was a little easy, right? Because there was connections between different entities. Again, if you have a database which is storing and retrieving data in network format, right? So such a database is what you call a network DB. Then you have something called object-oriented databases. So if you are familiar with OOPS concepts, this should be familiar, right? So in the case of object-oriented terminology, right? So what you do is whatever is common, right? That is put in the top. For example, if you have the, let's say you want to store details about dogs, cats, and some other, let's say monkeys or something, right? Or let's say birds. So in this case, what you will do is at a very high level, you will store data that is common to all animals, right? Irrespective of which animal is it, just because they are animals, there are certain properties associated with them. So those will go into what is called the base class or the animals class, right? And then you have what are called derived classes. Again, don't worry too much about it, just to get an idea, right? We will focus on relational databases, just to give an idea of what other types of storages look like, right? So under animals, you could have a category called, let's say, mammals, right? So mammals and non-mammals. So as you can see, mammals will have all properties of animals, right? But mammals will have their own special properties. So mammals have their own properties, non-mammals have their own properties. In addition, you say that they inherit the properties of animals, right? Because they are animals, they inherit all the properties of animals. Non-mammals will also inherit all the properties. So inheritance is one of the basic ideas in object-oriented programming, right? This is what we mean by inheritance. All the properties of the base class are inherited by the subclasses, right? So this is also called a relationship. So that means a mammal is an animal, right? So non-mammal is an animal. Then again, under mammals, you could have subdivisions, right? So you could have cats, you could have dogs, right? And because they are subclasses of mammals, dogs will have their own properties, right? So cats have their own properties, but because they are inherited from the mammals, right? So they are derived from the mammals, they have properties of mammals. And they also have properties of animals because they are also animals, right? So now if you want to store details about a dog called Tommy, right? So the dog ID is 1, the name is Tommy, some age is 2 years, right? So male dog, let's say a Labrador. So this information, right, which is specific to the dog, then properties which are common to all the dogs, properties which are common to all mammals, and properties common to all animals, right? The whole set of information is stored and retrieved in this format. So this is what you call object-oriented storage, right? Basically, how do we put information? How do you organize the information that we are putting? We can't just put randomly data in there, right? So there should be some kind of organization so that you can retrieve it very fast. So now what we are interested, okay, the third type then is object-oriented. But what we are interested in, right, because we are going to learn about MySQL, what we are interested is in the relational storage, right? So relational databases. So in the case of relational databases, data is stored in the form of tables, right? So a table is the basic unit of storage. So inside a table, you basically you will create a table to store details about a specific entity, right? So one entity, the details about one entity is stored in a table, right? For example, if you want to store details about students, you will create a table called students. Inside that, you will put student ID, right? So the name of the student, maybe the age of the student, and the course the student is taking, right? This is stored in what is called tabular format. So it's very similar to your Excel sheet, right? So this is what you call two-dimensional storage or tabular storage. So you have columns, right? Columns and rows. Columns represent attributes or characteristics of this entity called students, right? So this entity called students, whatever properties you want to store, those are stored in the form of columns, right? So you can call them attributes, you can call them columns. Sometimes they are called fields. Sometimes they are called keys. We will stick to rows and columns, okay? So this is the basic unit. So you first decide what all attributes about this entity you want to store, create a table with those columns. The actual data is stored in the form of rows or records, right? So this is where the actual data goes. So for example, you might store details about a student called whose ID is 100, name is George, age is 20, right? And learning MySQL, right? So this is what you call a record. You can call it a row, a record, a tuple sometimes, right? So actual data is stored in the form of rows, right? And columns decide what properties you want to store about this entity called students, right? So then you might have Mary, who's 25 years old, learning analytics. So like this, you will have thousands or millions of records in your table. So this is what you call tabular storage, right? Or 2D storage. And in relational databases, data is stored in the form of tables, right? So such a database, such a software, right? So this software will then be called instead of being called DBMS, it will be called RDBMS, right? So this is relational database management system, right? So now we have seen different ways of storing data, right? So there are different companies who come out with their own products, right? So IBM, like I said, was a leader, and they preferred storing data in hierarchical format. So IBM's product was called IMS, right? So the information management system. Similarly, there are different companies who create a software which stores data in network format, object-oriented format, right? What we are interested in is relational, right? So some of the main players in this area is Oracle. So Oracle is the company, right? And their product is also called Oracle with different versions of Oracle. So Oracle 8i, now 12c, right? So all those, 8i is there, I think 9i, Oracle 8, 9i, then 12c and all, right? So different versions are there, but Oracle is a company who comes out with different options of this software. So the product name is also called Oracle, right? Then there are other companies which come up with the different products like MySQL, SQL Server. You might have heard of PostgreSQL. Any other names you have heard of database servers?
MongoDB.
MongoDB belongs to a different category, right? So we will talk about MongoDB next. Other than that, Teradata, maybe. Informix. Okay, Informix. Teradata. So in this category, you have MySQL, right? So MySQL is a product which was released by some company, right? And they have given it the name of the product they have given as MySQL, right? If I remember right, My was the name of the daughter of that person. So he called it MySQL, right? So it's just like, so what is the difference between all of these, right? Because they all use RDBMS. They all store and retrieve data in the form of tables. They all use relational DB, right? So it's like, you can think of it like there are different versions of cell phones, right? Even if you take Android phones, it's not just one company that uses Android and releases phones, right? So you have Samsung, which is a company, and they have their own products, right? So Samsung Note is there. I don't know what else names are there. Then Nokia also uses Android. Again, Nokia has different product names, right? Although they all use the same Android. Then iOS, right? Your iPhones use iOS. So they come up with different versions of iPhone. So similarly, although the backend, the main software is the same, there are different companies, different products from each companies, right? So similarly, although the way we store and retrieve data is in the relational format, there are different companies who are there in the market. They come up with their own products, right? So each person they have their own what you call the USP, the unique selling point, right? So some might be very good in what do you say, security, probably. Some might be very fast. Some might have very good recovery and backup process. So some might be lightweight, right? So each company have their own specialty, right? And depending upon your requirement, you will go and choose one of these products. But what should we remember? All of them use relational database, which means all of them store and retrieve data in the form of tables, right? And they use the basic software that is used is called RDBMS, the specific version of DBMS, right? So it's called the Relational Database Management System. Okay. Are we fine with this till now?
Yes, ma'am.
So now the question is, how do we interact with these? So whenever an end user is interacting with the DBMS, he or she should talk in a language that specific DBMS will understand. So if you want to talk to relational DBMS, you should use a language that RDBMS will understand, right? And that language is what you call the SQL, or the structured query language. Query language. Although we call it a language, it's basically a command set, right? A set of commands that RDBMS will understand. Hierarchical DB will not understand SQL, right? So network DB will not understand SQL. They will have their own language, which could be very similar to SQL, but not exactly SQL. But all of these relational DBMSs, right? So all of these have the basic software inside it. So all these products will understand SQL. Right. So what we are going to do is we are going to practice SQL on MySQL database. Right. We are going to practice this language on this server. But once you master this, you can work with Oracle, you can work with SQL Server, right? PostgreSQL. As long as the database has relational DBMS, you can speak SQL to that DBMS, right? Tomorrow, you might start your own company and you might want to come up with your own database, right? So you could call it MyDB. But then it is your responsibility to make sure that the product you're releasing will understand SQL, because you are using RDBMS as your basic language, basic software, right? So usually people get confused between MySQL and SQL, right? So we get questions like, which is better? Should I learn MySQL or SQL? Right. So that is not the right question. So SQL is the language, right? These are all different products which use relational way of storage. Okay. So hopefully we have a high level understanding of what is the difference between different DBMSs, what we mean by relational DB, what is the difference between Oracle and MySQL. Oh, by the way, MySQL was later acquired by Oracle, right? So now Oracle owns both Oracle software and MySQL. And MySQL people have branched out and they have their own database now called MariaDB. Right? But all of these, if you learn SQL, you can interact with all of these. Okay. Do we have a high level view of these different databases?
Yes, ma'am.
Yes, ma'am.
So now, whatever we talked about, right? So everything that we talked about comes under the category of structured data. So when you say structured data, we know the format of data. We know what exactly to store and retrieve. So if you look at our students table that we created, right? So this is highly structured. Every record has exactly 4 columns, 4 attributes. And when you're creating the table, we also say what is the kind of data you're going to put into this, right? So when you create this column, you tell the server that I will put only integer values into it, right? Here you will say I will put only character type of data, not exceeding 30 characters. Here I will put only integers, right? So here also I will put only characters, not exceeding 30 characters, for example. So once the table is created, right, you have to stick to this. This is highly structured. There is, of course, you can go add a column, remove a column and all, but still, if you know that there is a table called students, you know exactly what you have to put into it, right? So you know into this column, I can put only integer. Into this column, I can only put character. Here I can put only integers. Here I can put only characters. And these are the only 4 things that I can enter, right? I can't have anything additional. So even if there are millions of records, every record follows this structure. So this is why this is what we call structured data, right? So we know exactly what to put, what is the type of data, what should be stored, what can be retrieved, right? But this is not always possible. It's not possible to know in advance, right? So what kind of data you're going to put, what all data you will have to store, right? All those, it's not always possible to know in advance. So one example is your social media kind of applications. You cannot predict in advance, right? For example, if you take Twitter or Facebook, you don't know what kind of content people are going to store. Sometimes it might be images, photographs. Sometimes it might be videos. Sometimes it might be just text, right? So maybe some audio MP4 or something. So we really don't know in advance what is the kind of data that people are going to store, right? And also it's not possible to predict in advance. You cannot create a table structure in advance, right? For example, if you take a Facebook post, for example, so what all information you have to store about a post, whatever you are seeing on the screen, they all come from some place where it has been stored, right? So there are so many things that you see on a page, right? What all do we see?
Likes and comments.
Likes and comments, but how about the basic content itself, right? The content itself, we don't know whether it is going to be an image or a text or whatever. Then likes and comments. Okay, let's create a table to store these, right? If I have to create a table like we did earlier, what all information? Probably the user ID, who's the one who's making the post. Then let's say the content of the post. Again, we have a question mark here. What is the type of data? Right? Will it be an image? I can never predict in advance. Then for likes, can I create a column called likes? Will that say, is that enough? What will I put here? It's not enough to say there is 10 likes or 20 likes. I should also say this person has liked it with this particular emoji, right? So the second person has liked it with a different emoji. So I cannot create a column called likes, right? Because there are so many things that I have to store and I don't know how many likes will be there, when the likes will come, right? So sometimes even after 1 year of posting, somebody might come and like your post, or they might comment on your post, right? Then coming to comments, how many comments should I store? Do I know in advance that there will be only 2 or 3 comments, or will there be 100 comments, right? Or then it's not enough to store the comments, there might be replies to this. How many replies? I don't know. Right? So I can't create 3 columns called reply 1, reply 2, reply 3, because I don't know how many replies will be there. Replies will have replies, right? So this will keep going and it will keep growing endlessly, right? So there is no stopping point. At any point in time, somebody can come and comment on it, and that might start off an entire discussion, right? So what we need is not structured data, right? So we cannot structure it in the beginning itself, saying inside this table, these will be the columns and this will be the data types. What we need is what is called dynamic storage, where the records can grow as required. It cannot remain fixed size like this, right? So you need a storage where the records can grow. Tomorrow, if there are 10 comments, one record will be a specific size. Second record might have 100 comments in it, which will be a different size, right? So you need something that can change as and when required. So such databases are called NoSQL databases. NoSQL term was used because they wanted to compare it to these SQL databases. SQL in the sense databases that understand SQL are basically RDBMS. Right? So relational databases with a specific structure. So here what we are saying is what we want is NoSQL, right? So something that is not SQL, right? So these databases are used to store unstructured data. Unstructured in the sense we don't know the format or the content in advance, okay? So just like we have different database, we have a heart of the database, right? For storing structured data, depending upon how you store and retrieve unstructured data, there are different forms of storages, right? Our intention is not to learn NoSQL, but still for the sake of completion, right? So there are database management systems for unstructured data. So depending upon how they store and retrieve data, there are different types of databases. One of the basic ways of storage is called a key store, right? Is your Python done?
No.
Okay. So in Python, you would come across something called a dictionary, right? So where you have key value pairs. So the data will be stored like you have a key and a corresponding value. So let's say you want to store details about student 1. So you might have a key called name and a value called Tom, a key called age and a value called 20, and a key called course and a value called MySQL, right? So this could be your first record. The second record could have more information or less information. You could have a key called name, let's say Pat, age, course, course, and maybe you also have information about marks for the student, right? Okay, let's give him 85 marks. So it's not necessary that every record should be of the same size or same data. Whatever information you have about a student, you can store it as a key value pair, right? The second way of storage is called document storage. Again, not going too much into depth. It is an extension of key store. So the difference here is a key has a value, right? So this value itself can be a key value pair, right? So for example, in our comments, in our Facebook post, right? So you could have a variable record called post one. So here you might have post ID, the first post, the user who's making the post, right? And then let's say you have something called comments. So the value itself can be a key value pair, right? So comment one will have a text for the comment and replies. Replies itself can be a key value pair, right? And then if somebody adds a comment two, tomorrow you can come and add a new key called comment two, the text of the comment and replies to the comment, which itself will be a key value pair. So as and when required, you can add keys and values to this particular key. So some records might be very large, some records may not have any comments at all, right? So this will grow as required. Right, so let's not go too much into details about it, but this is called a document storage. Then you have something called graph-based storage, wide column storage, right? So some products which make use of this kind of storage, key store is Redis is a good example of key store, right? If you have heard of a database called Redis, internally it stores data in key value pairs. So like somebody mentioned, MongoDB uses document storage, right? So data is stored and retrieved in document format. Graph, you might have heard of something called Neo4j, right? Wide column, probably you have heard of Cassandra, HBase, right? So when you talk about Hadoop and all, you might have come across these terms. So these are all different products, database products, which store and retrieve data in these formats. So these are your NoSQL databases, unstructured data, right? So dynamic storage, where the records will grow and shrink as required, right? So just to summarize, right? So let us put it all in one place. So we have DBMS, which is the heart of your databases, which takes care of storing and retrieving data. So when it comes to structured data, you can store and retrieve data in hierarchical format. You could store it in network format. You could store in object-oriented format. Or you can store data in relational format. So different companies that and products that are there here are Oracle, MySQL, MariaDB, SQL Server, Informix, and so many, right? So PostgreSQL. There are many such. Once relational database came into picture, it became quite popular, right? So there are many products which implement this. And all of these will speak the language of SQL or structured query language, right? So structured query language. And all of this deal with structured data. Coming to unstructured data, what are the different formats of storage? You could have key store. You can have document storage. Then you can have graph-based storage, wide column storage, right? And some popular examples of this, you have Redis, MongoDB, then Neo4j, then Cassandra, HBase. So all of this come under the unstructured data category. So what we are going to learn is SQL, and we will be practicing it on MySQL database, which comes under the relational DBMS, the database category. And the heart of this is called RDBMS, or the Relational Database Management System, right? So RDBMS has a set of rules which all of these products have to implement, right? Is this fine? A basic overview of different types of databases and data storage. So tomorrow, if somebody asks you the difference between Oracle and MongoDB, or SQL and MySQL, RDBMS and hierarchical, you would have an idea of what they are talking about, right? Fine?
Yes, ma'am.
Okay. So since you've already installed the server, the software, let's take a 5-minute break, right? And then we will come back and start looking at, let's understand what is a database and what is required, what you have installed and all that. Okay. And we'll get a feel of how to use the workbench. And then we will move on to different commands within the SQL command set. Okay, you have 2 missions. Okay. Yeah. Oh. You have done all this already?
Yes, ma'am. I have practiced your recorded lectures as well.
Okay. Fine then. You can open a new query tab, file, a new query tab. Click on file, top left, new query tab. Here, can you type show databases? Yeah, semicolon, control enter. Okay, you have many databases. Okay, fine. I think you can stop. I hope the others have also installed. So the reason I wanted one of you to share is because even I have many databases. But the moment after, once you have installed your server, right? As soon as you install your server and you type show databases from your workbench, right? So you have installed the server, DB server. Then you installed a client, which is the workbench which comes bundled with your MySQL. So this serves as the client, right? The purpose of having a client is to allow the end user to type some commands, right? And take the whatever the end user has typed, send it to the server, right? So the server will understand what you're saying. It will execute the command and it will send a response back, right? So this workbench is what you call a graphical user interface, because it allows you, it gives you this, that whatever you saw, right? So let me also open my graphical user interface, or a GUI. So this is a graphical user interface, right? Because it gives you all the, it gives you a what do you say, a visually convenient place to type your queries, right? It's not necessary to have a graphical interface. You can even have a command line interface, right? Which is what I will be using. The command line interface doesn't have a fancy look and feel like this. It's just a basic command line, right, where you can type your commands. So let me show you how a command line interface looks like. Right. So you can have just a plain looking interface like this. So this is not a graphical interface, right? This is just everything you have to type. There is nothing to click or drag or anything, right? So that if you have something like that, then you call it a graphical interface. This is a plain interface where everything has to be typed. So personally, I prefer that when you start learning, right, it's better that you use the command line because you will get familiar with the commands. Otherwise, you will have the tendency to click and look at the data, right? For example, you don't even have to know the command to see the contents of a table. You just click on this and it will show you what is there here, right? But it is better to sit and type this command so that you get, you practice the commands. Right, it's important that you remember the syntax of the commands, because even a small change, a small mistake, right, your query will not work. So, yeah. So you have installed the server, right? So you installed a graphical interface. So that is going to act as a client. So there are it's not necessary that the workbench only has to be a client, right? So just now I showed you the workbench, the command line can also act as a client. I can use the command line as a client. There are plenty of graphical interfaces out there in the market, which you can use, right? So dbeaver is available, which you can use as a client. DB visualizer is there, which you can use as a client. Even you can write a Python code, which can act as a client. Right. So what is the purpose of what is a client supposed to do? The client should allow you to type your commands. The client should have the ability to take whatever you are typing and send it to the server. And before that, the client should have the ability to connect to the server, right? And then take whatever you are typing and send it to the server. Whatever response it is sending, it should be capable of sending it back to the client also. So it doesn't matter, this interface itself doesn't matter. You can change it, right? Instead of workbench, you might use dbeaver, or instead of workbench, you can use command line, right? But these are all different clients. All of them will allow you to type your commands. Whatever you type will be taken to the server. The response will be got back from the server. Right. So let me show you, maybe I have dbeaver also on my system. So dbeaver looks like this. See, it's the same thing, right? So here I will type my commands. Close. Right, so I might type my commands here. Right, so this is what I use in my for my work. So here it will allow me to, it's not connected at the moment, but here you can type your commands. So you can see the look and feel is different. It looks slightly different from your workbench, but again, the purpose is the same, right? So I can type commands here and execute it. So it doesn't matter which client you're using, right? Only thing is your client should be able to connect to your, don't save, okay. Should be able to, so we have seen 3 clients now. Right, so this is one client, this is one client. It doesn't matter which client you're using. What is important is what you're typing inside it, right? If you know SQL commands, you can type it inside any client, send it to the server. Server will understand and respond with the result. Okay. So for our purpose, we have installed the workbench and the server. So when you install the server, there is nothing inside it, right? The memory of the database will be of the server will be fresh. We have not done anything. So now the first thing that we need to do before we start working with the database is to create a database, right? So how did we define database? If you remember, the first thing that we did was we defined what a database is. So we defined the database as a place where you can collect or store related data, right? So if the whole thing is the memory of your database server, you can select an area for yourself, right? You can say this place is where I'm going to put all my tables. This place is where I'm going to put all my finance related data. Here I'm going to store all personal data, right? Here I'm going to put all practicing data. So you can create separate areas for yourself and give it a name, right? So here you can call finance database. You can create a database called personal DB. Right? You can create a database for practicing. You can call it practice DB. Right? So once you demarcate these areas, you can, whenever you connect to the server, right? The first thing you need to tell the server is, see, this is the area where I want to work now, right? Or you can say, this is the area where I want to work now. So first thing what we need to do is, first of all, you have to create a database for yourself. Right? So create a database, enter the database, and then do what you want to do, right? So then you can create tables. You can put records into it. You can take records out of it. You can drop a table. All those you can do, but you cannot work without a database. Anything that you do has to be within a database. Right? So if you think of a company, right, if you are joining a company, the company will have different databases on their server. So they will have a server for HR people. They will have a server for salespeople. Sorry, database for salespeople. They will have a database for application developers, right? So they might call it AppDB. They might call this HRDB. They might call this SalesDB, right? So one advantage of creating databases like this is, like the definition, it allows you to collect related data in one place. So inside HRDB, you will have details about employees, their salaries, their performance, right? So their previous record. All those will be stored in the form of different tables inside the HRDB. Inside the sales DB, you will put all sales related information, right? So tables which store details about sales, right? So this will be inside the sales DB. Developers will use application DB. Here they will create tables that are needed for their own applications that they are creating. So one advantage of creating databases is it allows you to store data, store related data in a common place. Right? The second is it allows you to control access. So, so in your company, there will be a database administrator. He will create username passwords for people, right? So he might create a username called HR user and generate a password for him. He might create a user called app developer, right? And give a password. So once you join the company, you have to request whoever, they will create a username password for you, and they will give you access to the server. So what the DBA can do is, he can say anybody who's connecting to the server, right? Who's logging into the server using the app dev username and password should be given access only to AppDB. This person does not have access to the sales database, right? This person does not have access to the HR database. Similarly, anybody who's connecting to the server using the HR user password, right? So this person has access only to the HRDB. They don't have access to SalesDB or AppDB, right? So the second advantage of having databases, creating and maintaining databases, is that it allows you to control access to the data. You can say exactly who can access which part of the data, right? So without creating a database, you cannot do anything at all. So the first thing that we will do is to create a database for ourselves, right? You can create a database. You can give it any name you want. But before that, if you have not executed any command, right, and you have only installed the server, you can try typing show followed by databases, then a semicolon, and then press Control and Enter, right? So this semicolon is called a command delimiter. So this is used to tell your workbench or any client that you have finished typing your command. Because in real time, if you see, when you start writing queries, you could write queries on multiple lines, right? So you will be writing big queries, which will go to 40 lines, 50 lines, right? So how do you tell the server that, the workbench that you have finished typing all your query? This semicolon is the one that tells the workbench that the command is completed, right? So that is what you call the command delimiter. Control Enter is used to transfer your command to the server, right? Or rather, we say we are running the command or executing the command. Basically, we are sending this over to the server, right? So this is important because sometimes what happens is people type something and they forget to give the semicolon, right? And then they type something else in the next line. So what the database will think is the whole thing is one command. If you forget a semicolon here, the database will think the whole thing is one command and it will give you error, right? So this is important. This is to tell the workbench or the client that you have finished typing your command. Control Enter says now you can execute the command, right? So try this show databases and see what is the response you get. Semicolon and Control Enter and tell me what you see. What output did you get?
Different database available.
How many records, how many lines did you get? If you have freshly installed, you would see 4 databases, right? It is saying show databases basically says we are asking the server how many databases are there inside it. And it will give you 4 lines, right? So although we have not created any databases as of now, it will still give you these 4 databases. So you will see something called information schema. Then you will see something called performance schema. Then you will see something called MySQL. And you will see something called sys, right? So these databases are created by the server itself. Without these databases, the server cannot function. Okay. So the information schema contains what is called the metadata. So when you say metadata, it means data about data, right? Everything except the actual data will be available inside information schema. So information schema will contain details about how many databases are there. Inside each database, how many tables are there? What are the names of the table? What all columns are there in the table? Are there any indexes on the table? Are there any views on the table? Right? All that information will be available inside the information schema. Even how many records are there? Except everything except the actual records, the details will be available in the information schema, right? MySQL calls it information schema. Oracle calls it the data catalog, right? Informix calls it something else, but basically what it contains is the metadata. All database servers will have this, right? They might have different names, but every server will store the metadata somewhere. Performance schema has details about memory related information, right? So how much memory is being used, each query, how is it executing, right? All those details will be in performance schema. MySQL and sys will store a set of constant values, right? So these are required. For example, it might say max connections is equal to 5. So this means at a time, 5 clients can connect to the server. If more than 5 clients try to connect, it will give you an error. Why? Because the server has been configured to accept only 5 connections. So like this, should you start with auto commit on, safe update should be on. So these are all different information that the DBA will configure within MySQL and sys, right? So that you can set up your server and you can start the server in this mode. So these 4 are system databases without which your server cannot work. But what we need to do is we have to create our own database so that we can start practicing. We should not use any of these, right? If you mess with this, your server may not work as expected. So we will first create a database for ourselves and give it any name we want, right? So let's create a database and give it some name. I already have many databases. What name should I give? Tell me some good name for a database. No suggestions?
Practice DB.
I already have practiced DB. I have learned DB.
Demo.
Okay, demo. Okay, we will call it demo DB, right? So how do we create this? We will say create database demo DB, semicolon, and control enter. This should create an area for us, right? So once you create a database, we have to tell the server, I'm going to work in this database. And to do that, we will say use demo DB, right? So this is a one-time operation. Once you create a database, it is going to be there in the server, right? So this needs to be done only once. This has to be done every time you log into the workbench. The first thing you should do is use the database. Otherwise, what will happen? Any command you type, it will not work. You will get an error, right? And it will say database not selected. So whenever you see that, you can remember that you have not said use which database to use, right? So every time you open workbench, the first thing you have to say is use demo DB. Right? So it will take you to this area. Then you can create your table, select records, right? Update records, all those you can do. So let's do this. Let's create a database, right? And then then we will see. So we'll say create database demo DB semicolon command enter, right? Control enter. So if it is successful, you should see your command and a green color button next to it. Okay. And on the left-hand side, the demo DB should show up. If it doesn't, click on this button, right? So this is called the refresh button. Just click on this and you will see demo DB is here, right? Then you say use demo DB, semicolon, control enter. Now you can see demo DB becomes highlighted. So that means you are working in this database, right? Can you do these two things and tell me?
Yes, ma'am.
Yeah.
Ma'am.
Yeah.
When I'm opening my SQL, it's a black window is coming out. Can I share my screen?
Yeah. Okay, Deepak says done. Who was that? Who wanted to share?
Ankita.
Ankita. Okay. Yeah, I've given you permission. Oh, you are using the command line. You don't have the workbench? Type
I
exit.
have, ma'am. I have. But today it's opening like this.
Type exit. EXIT.
Enter.
Enter. /quit. It's there on top, no? /quit.
Okay.
Enter. Okay. Click on the search bar. Click on that. Type MySQL workbench. The next
This one only, no?
No. Below that you see
Workbench. Okay, fine.
Click on workbench.
Okay, fine. Got it.
Why you don't have any connections?
Because
Yes.
I haven't done anything, ma'am.
Or you didn't install the server also?
No, I have to install this.
Then you should have a connection. Can you click on plus MySQL connections?
Okay.
Give it a
Paste.
name. Give it a name, some demo DB or demo or something. Yeah, click on test connection. Unable to connect. You have to see how you installed it. It
Okay.
looks like your server is. Can you click on configure server management? Bottom left. Next. Something wrong. Unable to connect to localhost. All right, I think we need to check out, or it would be good if you can uninstall and do it from the beginning.
Fine.
Yeah.
Can you share a link, ma'am, from where to install?
Just mysql.com.
Okay, fine.
Yeah, okay. If time permits, we will see. Today, probably we let us stop a little early.
Fine.
But from tomorrow, we will have 10 to 12. Today, maybe around 11:45. Let's stop because it was kind of sudden. Your class came in at the last minute. Okay. Yeah, we will check it out. Okay. Right. So the others, if you have created, right? Now let us, so now that we have created a database, right? So we have we are inside the database. Let's try to create a table, right? So before creating a table, we have to decide on the name of the table, then what all columns we are going to put and what are the data types of it. So we'll create a table called students, like we did some time back. We will have an ID for the student. Let's save the name of the student, then the age of the student, and the course the student is taking, right? Now, we should also say what is the type of data we are going to put inside it. So let us make this integer. Then we will make this character of 20. We'll see these data types in detail, but for the moment, let's do this. So character of 20 means we are going to put character data into it and we will not exceed 20 characters. Right, so we are not going to give a very big name. We will stick to names which are lesser than 20 characters. Right. So once you decide on the columns, the data type, right, we can create our table. So how do we create a table? We will say create table. Or before this, if you once you go into your database, right, if you say show tables, it will say there are no tables in this database at the moment, right? If you say show tables, semicolon, control enter, basically we are asking inside this database, what are the tables available, right? So since we have not created any tables, you don't see any output. Tables in demo, there is nothing here, right? So now let us create, I'll give you time, right? So just try to focus on the syntax. So create table, right? So the name of the table. Then you have to open a bracket. Then you have to give the column name, data type, column name, data type, right? Student ID is of type integer. Then give a comma. Then the next column name is student name. Data type is character, not exceeding 20 characters. Again, give a comma, right? Now, the third column, which is age, the data type is integer. Again, give a comma. And then what is the last one? Course, right? Course, the data type is char of 20, right? So now no more commas required. Then close this bracket, right? So this bracket you will close, semicolon, control and enter. Can you try this and see if you are getting, if you get any error, let me know. Or let me type, right? And then you can maybe look at that. So here, so whenever you are typing commands, it's better to type it on multiple lines, right? So that it is readable. So we'll say create table. You can type it on one line also, but it's better to write it like that. Open bracket, right? And then what is the first thing? Student ID, which is of type integer, comma, student name, which is of type character of 20, comma, then, spelling, CHAR. Then age, which is of type integer.
Ma'am, it is necessary to first letter capital.
No, MySQL is not case sensitive. So whichever way you give it, will take it.
Okay.
Right. Course is char of 20. Close the outer bracket, semicolon, control enter. If your command is successful, you will see the command here, and next to that, a green button. Right. On the left side, click on the refresh button. Under tables, you will say see students. Do this and let me know.
Ma'am.
Yeah.
Ma'am, what is the difference between the worker and char?
We will see. We will see each and every data type, and we'll see when to use which one.
Yeah.
Right. Okay, Vrishali says done. Let's give it another minute. Okay. So some people have done, right? So after you create your table, right? So one way to verify, of course, if you have a user interface, you can see it on the left side. But what if you don't have a user interface, right? So in that case, what you can do is you can say describe, DESC, followed by the name of the table. So this will tell you at the table. So I personally don't like this interface at all. So that is, I'll be shifting to the command line shortly. But for the moment, you can see it says this table students has these 4 columns. These are the data types, right? So this tells us that the table has been properly created, right? So now that we have created a table, let us put some records into it, right? So let us enter some data. So we will put student 1, whose name was George. He was 20 years old and he wanted to learn MySQL, right? So to do that, we will say insert into students values. And now you have to give values in the exact same order in which you created the table. So if student ID is first, that is what you need to specify first, right? So you will say 1. Next, we have to give the name of the student. So anything other than numbers have to be entered within quotes, right? So you can give single quote or double quote. So you will say George, comma, age is a number. You don't have to give it within quotes. Course is not a number, so that you will give within quotes. Close this, semicolon, control enter, right? So let me type it here. So we will say insert into students values.
Hello, ma'am. Sorry.
Yeah.
Can
Yeah,
you
tell.
share this data, ma'am? It is analyze the assignment. This left side is data is there. That not showing my screen.
This one?
Yeah, ma'am.
Okay, just give me a minute, just a moment. Yeah, sorry. Let me finish typing this, right? And then I'll take a look at yours.
Okay, okay, ma'am.
So 1, then who was the person? George, no? So George, then he was 20 years old and he wanted to learn MySQL. Close this, semicolon, control enter. So if your command is successful, you will see your command here and the green button, right? Insert George and you insert one more student of your choice into the table. Meanwhile, is it okay if I stop sharing and look at somebody's screen? Okay. Yeah, who wanted to share? Somebody had a problem, no? Who was that? Hello. What happened?
Hello,
Yeah, who was it?
ma'am. Myself, Balaji, ma'am. It's not showing data, ma'am. I
Yeah,
shared the
yeah.
screen, ma'am.
1 second, I have to give you permission, I think. Balaji, I don't see Balaji. Have you logged in with a different name?
No, ma'am.
Okay, let me search.
It's showing new
Ah,
NEW.
I think new only, no? Yeah, new you can share.
Hello.
Yeah, Balaji can try.
Yeah, ma'am. Yeah.
Click on your workbench. Can you go to view
View. Yeah, ma'am.
panels? Or it's okay. You go to top right, you see under the close button, you see 3 boxes. top right, top
Top.
right.
Yeah, this one, Amma.
No, the first one you click.
Okay.
Then tick. Now you see.
Another data is there, ma'am. App, employee, HR, no.
I think you didn't create can you click on the first line? Place your cursor at the end of the first line.
First, yeah.
Line number 1. Place your cursor at the end of the line. After demo DB.
Yeah.
Control enter. Did you do?
No, yes, ma'am. Control.
That 3 boxes. Okay. You have already created it. Can you click on the refresh button?
Refresh. Where is it?
That is the one. Down. Next to schemas capital.
one.
Yes. Click on it.
Okay.
Yeah. Now you can see demo DB.
Yeah, ma'am. Okay.
Now
First line is your control enter, ma'am.
control enter. Yes.
Create the database in a demo. DB is a control enter. You put the data is came.
Control enter is to execute that line, right?
Yeah.
You said create database. So use demo DB also. You have to press control enter. Line number 2. Place your cursor there. Control enter. Yeah.
Yeah, ma'am.
Now you can see it is highlighted. Now you can create your table.
Okay. Okay,
Fine.
ma'am. Thank you.
Yeah. I am stopping your share.
Okay. Thank you.
So meanwhile, hopefully you guys have inserted a record, right? Let me insert one more record. So we'll say insert into students. Let's put Mary's details, values to Mary, let's say 23 and learning analytics. Don't forget to give, don't forget to give quotes where required, right? Semicolon, control enter, right? So now if you want to see whether the records you have entered is there in the table or not, you will say select. Don't worry about the commands, right? So we'll be looking at them one by one. But for the moment, let's say select star from students, semicolon, control enter. You can see George and Mary in your table, right? Do this and maybe today let us stop a little early. If anybody is facing an issue, let me know. Okay. So if you're done, please feel free to leave, right? So just for today, a little early, sorry.
No problem, ma'am.
Yeah. Yeah.